The broadcast is now starting. All attendees are in listen-only mode.
Welcome everybody to this Safety Lore webinar that is the Lessons Learned publication of the iChemist Safety Center. As you may know, and many of you have been here before with me during these webinars, this is the 9th issue of the Safety Lore that we have published so far. And the upcoming one, the number 10, is about alarm management. That is going to be published soon in a few weeks' time, and then after that I will organize another webinar. So this is the last one so far that is completed, and it analyzes key lessons from incidents related to permit to work. Now, before I start, I'd like just to briefly introduce myself. My name is Dr. Zuzanna Gyenes. I am the Deputy to the Director of the iChemist Safety Center. I'm really pleased to be here with you, and thank you for joining in this webinar. As you may know that after the webinar, I share the video on YouTube, on our YouTube channel, and normally I share it on LinkedIn as well. So you can find us on every forum. Basically, I will give you the details in the end of the presentation. And before I start really with the topic, as you can see that you have the question box. And the question box is, interestingly, is not only about questions. And because I would like to kindly ask you to give your opinion, to give your thoughts as always. That is really helpful, and I think that sharing our knowledge and experience in the topic helps us to understand it better. And because you see, this is a publication that is a 2-page format publication. Obviously, I cannot reveal all the information or give you all the recommendations which is covered by the topic, and especially if you think about permit to works. So let's jump into the topic. So permit to work system is a really complex system, and it is done in every industry somewhat different. And that is also the reason why the iChemist Safety Center with its company members decided to publish a guidance document on permit to work systems, how it is done, how it is working in practice in different industries. And with the technical working group, we are now working on this document. It will be published, I think, by the end of the year or maximum first part of next year. So it is such an interesting topic that we really have to deal with it. So let's start and let's see what we mean by permit to work systems. The most significant accident that we all remember is Piper Alpha in terms of permit to work systems. But as we can also mention Texas City disaster. We have to mention, of course, Pasadena 66 and so on. There are so many accidents, not only these high visibility ones, but also others as well, where permit to work systems failed. And so these are demonstrated. The permit to work system is an essential part of any non-routine hazardous activities in industrial sites. And issuing a permit to work document itself will not make the job safer, but the content needs to reflect the real situation, trying to identify all hazards associated with the task and all risks assessed. It also describes how the job must be carried out safely, introducing all precautionary measures, and of course the expiration of the permit. After completing the task, the permit to work must be closed with checking that the job was done following the instructions in the permit. So basically, I put here a very short definition that the permit to work system is a formal system stating exactly what work is to be done, where, and when. And now let's see what are the 2 cases that I brought today, and then the lessons learned. The first case occurred in a chemical plant. 2 contractors were performing welding on the top of a slurry tank when hot sparks ignited flammable vapors inside the tank, causing an explosion. I muted myself. No, I haven't. You are back. Okay. No, I think that was just a pause that I was thinking. So no, I haven't muted myself. Right. So two contract workers welding atop of a slurry tank when hot sparks ignited flammable vapors inside the tank, and it caused an explosion that unfortunately killed one contractor and seriously injured another. The accident occurred at a chemical plant that produces polymers and surface materials. The process for making the final product involves transferring polyvinyl fluoride slurry from a reactor through a flash tank and then into 3 slurry storage tanks. The 3 tanks, tanks 1, 2, and 3, were interconnected by an overflow line. What are the key learning points? Days before the incident, the process had been shut down for tank maintenance due to corrosion, and the slurry tanks were locked out so the tanks can be cleaned and entered. Tanks 2 and 3 were repaired, reconnected the process piping, and the valve locks were removed to prepare for restart. Tank 1 remained out of service because the necessary parts were not available. When the repair materials arrived on the site, a contract welder and foreman were engaged to repair the agitator support atop Tank 1. Although Tank 1 remained locked out from the main process, the overflow line remained open, and that open line connected Tank 1 to both Tanks 2 and 3. The overflow line to all 3 tanks was never blinded. The investigation found that flammable vinyl fluoride flowed through the overflow line into Tank 1, where the welding operation was ongoing, and accumulated to explosive concentrations. While a facility hot work permit was issued for the task, the site personnel who signed it were not sufficiently knowledgeable about the chemical process. Although they monitored the atmosphere above the tank prior to authorizing hot work, no monitoring was done inside the tank to see if any flammable vapor existed there. The company's hot work permit procedure didn't require testing the atmosphere inside the tank for flammable vapor. Site personnel did not properly isolate and lock out Tank 1 from Tanks 2 and 3 prior to authorizing the hot work. The company's process hazard analysis incorrectly assumed that vinyl fluoride in the chemical process could not reach flammable levels in the slurry tanks. The flammable vapor was able to pass through the overflow line onto the tank where the welder was working, unknown to them or to the operators who signed off the hot work permit. And I think that from this case, we see many similarities to other cases. And this is such a typical problem, such a typical issue when there is no lockout, tagout, or there are 1, 2, or 3 tanks interconnected with each other and they are not isolated properly. And if you look at the CSB, the Chemical Safety Board in the United States, how many similar accidents they investigated and how many findings you will find there and recommendations, it is still happening. So such accidents are still ongoing and still occurring, apparently because the staff actually doesn't understand what is the process itself. They are not aware of the circumstances. They don't know about the hazards. They don't know about the consequences that could occur and that could be impact. And also, there is no hazard identification for the process is ongoing. And somehow, some information is getting lost in the permit to work. So it is unclear. And so these are just key learning points, but this is just one case However, you can see many similar issues with other cases as well. But let's see what I have in the second case. On 5th November 2005, 2 employees from a subcontracting firm died by suffocation during maintenance work conducted on the hydrocracking unit, as they were raising a pipe onto a reactor inerted with nitrogen. One of the technicians fainted and fell into the reactor while attempting to pick up a roll of adhesive tape. The second victim was also asphyxiated in trying to save his colleague. Now, briefly, this is the case, and I think that you also have seen such cases before. Asphyxiation, falling into the reactor, and the other colleague who tries to help his colleague or her colleague, and therefore both of them died. Unfortunately, when I was preparing this safety law, I've read a lot of such cases. And this is unfortunate that it's still happening. But let's see what are the key learning points. Maybe we can reveal some of those, and maybe that you are listening to this, then you can check your permit to work system and then fix some of the points if you find them useful for your operation. So what happened here? This hydrocracking reactor had been shut down for maintenance. You see, this is most of this story start. It was during maintenance. It happened during restart. It happened during this or that operation, but mainly maintenance. Its nitrogen supply line had been temporarily closed to enable reloading the reactor catalyst. This operation required preliminary dismantling of a large-sized pipe bend. Once the reloading step had been completed, the manhole was protected by a plastic tarp and nitrogen could once again be injected. Refinery employees placed the red tape around this manhole along with a sign reading, "Danger, confined space, do not enter without permit," yet without indicating the type of hazard present or the risk of asphyxiation. A subcontracting company raised the elbow to restart unit operations after receiving the refinery's authorization to initiate work. A permit then was issued for the operation. The document, however, did not specify that the reactor was filled with nitrogen. In response to the permit form's questions whether a nitrogen purge was required as part of the operation, the NA box had been ticked. One of the subcontractor's employees removed the protection and noticed plastic tape inside the reactor. Now, reactor cleanliness criteria prohibited leaving the tape inside the reactor, so the workers looked for a way to retrieve it. Any entry into the reactor requires a specialized team and specific approvals. The technicians assigned to this task expressed concern over the appropriate course of action. Installation of the elbow had to be completed before the end of the shift, but sticking closely to the procedure would have slowed their progress. Moreover, the crane needed to conduct this operation would not be available afterwards. To avoid this inconvenience, a technician unsuccessfully attempted to pick up the tape using an iron wire. Whether accidentally or intentionally, he fell or entered the reactor and passed out. His coworker on the exterior platform then climbed down to rescue his fellow team member and fell unconscious. The oxygen content measured by rescue workers inside the reactor was less than 1%. So this was the second case where apparently there was a lack of information in the permit to work system, and there was another issue, contractors, subcontractors, plus that they were really in a hurry, so that they had to finish work within their shift. So therefore they bypassed the procedures. And I think that we have discussed it in previous safety laws, which was such an issue in other cases as well, relating to shift handover or any other types of such as startup, when the operator really wanted to start again the unit, and therefore they were in a hurry, they were stressed. So these are really typical underlying issues that happen when there is an operation that you have to finish in time. So then the second part of the safety law is to think about, what can I do? What can you do if you are a manager, if you are a process engineer or a supervisor? What can you do as an operator in order to avoid such cases to occur in the future? This is the part where I give some tips and recommendations based on these roles around the 6 elements of the iChemist Safety Center framework, which you can see here on this slide with different color dots, such as systems and procedures, engineering and design, assurance, knowledge and competence, human factors, and culture. So when you visit our website and download the PDF document, then you will see that all of these recommendations are associated with each element. And then you will see which element is related to that particular recommendation, so that it gives you such a structured way of thinking, a structured way of what can I do as a manager, because those are the recommendations that are specifically are my roles and responsibilities, and so on. So let's see, what can I do as a manager? Develop a permit to work system that is implemented in the company and that is kept up to date via a periodic review procedure. Make sure to implement lead process safety metrics to measure the effectiveness of the permit to work system applied in the organization. Develop procedures to conduct confined space control and inert gas purge, and make sure that training is provided for all affected personnel and contractors. Make sure that the audit on the permit to work system is thorough to avoid it to become a routine administrative process. Make sure that those in charge for control of the maintenance work are identified within the work permit system, and that the work is properly authorized by a responsible person. So this is what I collected as an information that as a manager you should ensure, or you can ensure. But of course you have more than this, so you feel free to add your suggestions and any other recommendations from your practice, because that is really interesting to see how other people see this, and what do you think that management should do about permit to work systems. There is actually a lot of literature and reference materials about permit to work systems, so you can get the information, and you have some very good recommendations published by different organizations on the internet, so that is really good that we have those information available. And so let's see now what a process engineer should do or could do, and a supervisor should or could do about permit to work systems. Make sure that hazards are identified and risks assessed associating with the hazardous activity to be completed, and all hazards are communicated clearly with those involved in the task. Ensure that adequate process and electrical isolation are in place, that no hazardous materials are introduced to the work area, and no prime movers such as motors, turbines, and engines can be started accidentally during work. Verify that the necessary precautions are taken prior to entering confined space to check safety at each stage, and may need to remain present while work is underway. High-risk activities require positive isolation by inserting spades and blinds into lines, or disconnecting lines to physically separate the workpiece from any possible introduction of hazardous materials. Make sure that danger signs or other equally effective means to identify the hazards are posted in the hazardous area to accurately warn workers about the asphyxiation hazards. Make sure that all hazardous energy sources are identified, isolated, and rendered inoperative to prevent the release of energy prior to the start of any repair or maintenance procedure. Make sure that operators are equipped with proper personal protection equipment suitable for the task being performed. Make sure that only qualified and trained personnel equipped with the necessary safety equipment should attempt a rescue. Pay attention to any violations of the permit to work procedure, as it can increase the risk associated with the hazardous activity. So these are the thoughts about what a process engineer or a supervisor can do about to avoid such cases to occur in the future. So these are my collection of thoughts for process engineers. However, you may have more recommendations from your practice. So I'm really happy to see that. And I'm really happy to learn more about those if you have some of those in mind and if you would like to share them with your colleagues as well. And as you know that the last part is when I give some recommendations. What can I do as an operator? So make sure you only complete work that is covered under the task description of the permit. Any additional job may not be checked for potential hazards. Always follow the permit to work procedures without taking any shortcuts. The procedures must be adhered to all the time. Obtain a permit before conducting any work that involves confined space entry, work on energy systems, hot work, ground disturbance. Check if the work can be done another way to avoid entry or work in confined spaces. Ask your supervisor if there is an alternative approach that can reduce the need for confined space working. Make sure that energy and material flow sources are identified and controlled, isolated, logged, tagged properly. Be aware that hazardous, oxygen-depleted atmospheres may be present outside the confined space as well. For example, near openings, and that acute oxygen deprivation rapidly overwhelms the victim without warning. Unprotected entry into an oxygen-depleted atmosphere for any length of time, no matter how brief it is, can be deadly. So these are from the practical point of view, as you know that this is the collection of thoughts that I brought today. And I know that there's a lot of other things and potential recommendations that you can add, and I think that we have some questions. Yes, lockout, tag out, and try out. Okay. That is an important aspect of permit to work systems. And if you want to read the PDF version of this safety law, then it is published on our website. We are still waiting for the Spanish translation because as you can see that all of the safety laws are translated into Spanish language, and the law is also available in a podcast MP3 format on our website. And this is what I wanted to tell you about permit to work systems today. And of course, you will find us on different media, and you can see our email address, the website details, and as I promised, I will upload the webinar video to the YouTube channel, and also I will share it on LinkedIn. And we have more recommendations. So under management, I would add to ensure people are trained, competent, with good records in place to validate. That is a really good observation. Thank you for this. And that actually reminds me of the importance of the competency of the recruitment or the HR departments because they are also responsible for hiring contract workers, and they have to know who are trained, well trained to do the work. So that is, thank you so much for the reminder. And there is another comment. Supervisors, okay. Supervisor needs to audit live permits to ensure that controls are being properly implemented and that personnel truly understand all hazards and controls. Is an excellent lead process safety metric. Thank you. Thank you for that. And I highly agree. And these are really important matters and really important aspects to this. And if you have more, then please just share it with us. Okay, from the management perspective, there is another comment. Need to provide teams with a system-proven permit to work where cross-team involvement from maintenance and operation is enabled. Yes, and this is a cross communication, so communication cross site, and that everybody is really everybody understands. Sorry. Okay, once again, so that everybody understands what is going on the other part of the site, because that is that you don't start working on some systems while you know that there is a maintenance or painting or cleaning at the other part of the industry. And I have seen such software tools. I don't know them, I haven't used them, but I saw them, that they are in place, that you have such a system in your operation where you can see what each part actually are doing at the same time, so that you can control the work more properly. So thank you very much. And please feel free to download the PDF version and share it with your colleagues because it is for free. And share this webinar video with your colleagues if you think that it has added value to your operation or to your clients. It's also free. And thank you so much. And see you in a few weeks' time with a very, very tough topic on alarm management. So thank you very much again, and goodbye, everybody.